entertain you and get as fast as possible so you get your food. So, ZWEIDENKER is a company Cologne I told you already. So we were founded in 2009. So when you come to ESUG next year, there will be some kind of 10 years party maybe. In the meantime, we have 13 people, Germany, and one is in Ho Chi Minh City even. And we do mainly do iPhone, Android, web and backend development, and we try to push Pharo. And that's what we are telling about, is the latest, biggest Pharo project we have so far. So, we are telling a little bit about server infrastructure, application deployment, monitoring, and the workflow, how we can fit, how all of these can fit together to make a team development effort, which works and does not get out of control. Yeah. The project is a mobility broker for Airbus. I mean, Airbus, I think most of you know, it's a big company, 35,000 employees in Germany. The requirement was that at least 10,000 people are users and they're frequently using the tool. So it's not about 200 per day, it's thousands. And if you know what a peak means, you need to be prepared. And we know that you cannot do this in a single image. And if you don't have a single image in Pharo, so you open a can of worms. So you have to deal with all of it. The approach we took is the modern way of buzzword alarm. It's microservices, but at least we said we need to partition the domain and we have to load balance and distribute them as much images as we can. So we are prepared for peak and really high loads. I am. And yeah, now Pierre will tell about what is the usual workflow we do in order to get this done.
Okay, so we start with the workflow here on Pharo, obviously, and starts with the regular day of coding at the office. Coding, so here, classic stuff everyone can relate to. Now I'm done with working, I want to share this with my colleague, my boss, show what I did, so how? Obvious answer, iceberg and Git. What else, anyway? Then I commit, push, create a pull request for my feature branch, and then one of my colleagues, my boss, someone will review, and if he approves, he will merge it. That's when Jenkins come into the game. Jenkins will look and for what's up every 10 minutes, and pull, run the test. If the tests pass, Jenkins will start to play with Docker. I will give a very short intro for Docker. So Docker, you can think about it as a small dog image, but for Linux. And you have Docker image that are built from description Dockerfile, and this image are runnable. You can run it once or multiple times as a container. So Jenkins, after the test pass, will build an image and push it to our Docker repository here. So at this moment, we have, for every repository, we have the build. The build will create an image, and now we are potentially we want to deploy a lot of containers.
And this is where then I come into play, and so we do have a lot of containers in the mix. So we do have all these Pharo images that are the microservices. We have a web server. We have a message queue that is used for communicating between Pharo and between the other parts. We do have a database. So the question is, how do you actually now script this whole stuff in a way that you don't have to do this manually, that is repeatable? And for that we actually use Ansible, which is a way to script both typical Unix admin things like the installation of software, and it can be used to set up the machines for deployment. This actually it's implemented in Python, but it uses YAML as kind of declarative specifications for your scripts that you provide, which in the end is actually extremely painful. every time we are working on this, we think it would be nice to have a Smalltalk debugger for YAML playbooks. So Ansible playbooks describe our deployment, and the deployment happens with Docker, but not Docker just like that, but we use actually Docker Swarm. So Docker Swarm is a part of the Docker distribution, which allows you to distribute Docker images over multiple machines. And it allows you to actually define services which consist of multiple instantiations of a Docker container. So you can actually make one Pharo Docker container and then say, okay, Swarm, please start it up 5 times. And it will automatically be started. The Swarm manages distribution, so if you say, please start this Docker image 5 times, it will actually be distributed over all machines automatically. When you restart, it will actually do it nicely so that your service will not be interrupted and things like that. So this means we are now here where the Docker Swarm is active, and then the next step is how do you actually keep control over this relatively large installation, and there the monitoring part comes into play.
And me again. Yeah, but deploying a system is only half of the work because you need to keep it up, because we know systems tend to kill themselves. So the one thing you should always do is monitoring, meaning that you grasp enough data of all your machines and all your system, so you can plot and extrapolate problems, and you can see, get notifications about actual problems. So one way of doing this is, we're using a tool called Grafana because it looks really nice. Here you can get all the stats you grasp on your image. It's collected every 15 seconds, and then you have a time series database, and you can make queries that you want in order to see that is my key requirement of the system, and I can also put thresholds, and that's the important stuff. I can, on every value I make from the query, I put a threshold with an alarm, and I'm saying something like easy would be if system load goes over 10, so please notify me by mail, or we use a Slack channel where the Grafana posts to. It's kind of a disk space. Or even if there is, because we also have the metrics export for Pharo images, so we export, for instance, the heap memory, garbage collections, sync requests and sync responses. So at least there's alarm on something like sync responses for HTTP 500 and up, because that's something you don't want to have, so you want to have immediately. So you can trigger the system, or configure the system so you get all the necessary data that you don't have to look yourself all the time. The same we do with error reporting. So, meaning that when an error occurs in the application, we can upload the fuel dumps. So a few of you maybe know that in Pharo they have the possibility to dump a fuel context, an exception context to a file. And in our Swarm, this is uploaded to a central server. And from the development image, you can connect to the central servers and just saying, okay, for my product at this version, so just show me if there's current errors. So anyone using Gemstone, thanks for the idea, might know this because you get a list of all the exceptions. You click on it and a debugger pops up on your development machine. So it could be closing the cycle, having in a debugger the code change to committed, reopen iceberg like Pierre told where we started the process, and then it can go run it on. So that's our, did I forget something? Yeah. Okay, this is another recap of the whole system. It's just where you have a web client, a web browser, local answer, the basic business logic API, and then as we are a mobility broker, we requesting every search attempt from a customer. There's you can drop by bike, by car, by trains, or by buses, and this is all done simultaneously, distributed throughout the Swarm. Yeah, and these are the real machines. Just another view on the same thing, that we have physical machines that we put together to a Swarm, and then we have an abstraction where you can have one service, which is basically a Pharo image running, is being distributed over the physical machines, and we don't know where, just because the swarm is saying, I want to have 4 or 14 of it, and then it goes and looks where is the best place for putting the container. It's transferred and started on the physical machine. And on the low, you can say that overall of the machines, there's a database cluster, so each machine can easily have the distributed database in access to. And as you have the testing and stuff, you need all of these swarm stuff 3 times. So we have one swarm for alpha, one for beta, one production. The good thing is because the swarm does not care about if it's a physical machine or a virtual machine. So the alpha and beta are physical machine swarms. And the production swarm is a couple of real physical machines. That leads up to over 100 Pharo images running right now. So we definitely want Pharo 7 and no morphic, because in our machines it's 2% morphic stepping, and on 100 images it's 2 CPUs at least that only do morphic stepping, so we want to change that in the future. And the good thing about the Docker and all this setup is that the whole stack you can run on your laptop too. With a similar command, you can load and start everything you have, the whole architecture on your laptop, if you want to have inside debugging and stuff where you want to get in touch. And this presentation might not be the most Pharo internal stuff, but for us it's one way that we try to make the tools to make this swarm stuff a little bit more of a Pharo experience. So we started to do a Docker engine API client, which means there's a Docker daemon that orchestrates everything, and you can open a TCP port, and then you can talk JSON REST stuff. And we have starting a client, so we can access all of these. And so maybe you can even use this client for starting, stopping, and reorganize the Pharo swarm. So we could maybe return the wheel to saying, we have a swarm with Pharos, but we can also use Pharo to control the swarm. And as an example, you did here a short ROSA visualization of the swarm. The gray boxes are the physical machines, and the green, light green ones are the containers that run on the machine. So, but by clicking, so maybe we could make a nice client where you can step through the swarm and even maybe have a debugging hook in the future to get access to one Pharo container directly. Yeah, I said there's much more. In doing the project, there's a lot of stuff we need to open source. We didn't do everything now, but we have a pipe of the Docker engine, needed also implementation of Open API, which we did. All of this is started, and we like to do help. Like to have help. There's even Docker health check is something we hooked on. There's Docker, there's a URL you can configure, so the Docker daemon contacts your image all the time, and you can say, okay, I'm healthy or not. And we hook this onto the SUnit stuff, so you can write system tests where you can say, my assertions are a healthy system, and if they fail, the health reporter just saying it's not good, and then the container will be shut down and another one will be put up. So, yeah, and as we have a lot of these APIs and stuff, this is the last line, so there will be show us your project, and we're happy to, if anyone of you is interested, to show the one or the other APIs we're doing right now. So talk to us if you're interested. And yeah, we're missing the last slide, but thank you.
Any questions? Oh.
What sort of volume of requests is this configuration handling in production?
The volume of requests?
Yeah.
What do you mean?
Requests for service in terms of information scheduling, etc., and monitoring the volume of user requests?
At the moment?
Yeah.
The tool is not yet fully live, so there's not yet all the loads going there. So there will be another lesson, because we always can go for scale. And then when the request comes in, you see, oh, I didn't think about this, and then you have to queue. But at least we have the infrastructure where we can build the stuff. So there's no official hindrance that will keep us from having. I will expect there will be, I think 200 requests per second should be easy. And I don't expect it to be much more things. We have some services, so along this is not the only project. And there's a couple of 20 requests per second, and the infrastructure don't even notice. So there's no CPU load, so there is the background noise, more or less. So I think 200 of that is easy. Martin?
I would like to know, you just described the Pharo part. What about the database part you just mentioned, the distributed database? What do you use there, and is the database itself also under control of Docker? What is it scalable, the database, and what do you do there?
Yeah, it counts for both the RabbitMQ, it's the message queue we use, and the Mongo. So both products in the meantime have cluster support. So that means if you look from Docker, I mean, if you use Docker, you know Docker container. So that's always an image, is the thing that started, one is a container. And in the Docker Swarm, this is a service, so the abstraction. And you can arrange these services as you like. So the basic thing is that we start on each worker machine. We start a database, and then you can, after this with Ansible, it's really easy to inject the JavaScript so the database server find each other and then build a cluster. So in MongoDB, which we are using, it's pretty easy because you just have the IP addresses or the names, and then you're just saying, hey, I'm opening a new cluster, and you and you and you take part of it. And then you store, and then one of these, it will be the master. So it's finding the master, talking, at least writing requests to the master, and reading requests you can disparate. And the RabbitMQ is the same stuff. So there's some optimizations where you have, because you always create queues and stuff, but this is distributed transparently. So we just make these scripts that you can have basically an arbitrary number of hosts, and then you just install in all of these. Because you can, each host and stuff you can label. So you can say, this is my role, la 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 la, and then you can make all the scripts running on the role, such and these, do this and this. So you can, even if you have 100 machines, you can say these 20 are the database servers, then you just label them, and then you say the script on each machine that is labeled with database, go create a service, and for all of them say, you're a cluster. So it's not fully reliable. Sometimes we have to reboot the machines, which nearly never happen. We nearly never have to do. We have to rearrange a few stuff. With RabbitMQ, for instance, it's not fully reliable that it recovers. But we have also a script, so when we do the physical machine reboot, we have to take caution afterwards, but most of the stuff just comes up on its own. Answered?
Yeah.
I was interested, what do you use for load balance? You mentioned there's a load balancer that splits.
Yeah, load balancing is always a problem, and our biggest problem is that our provider does not support a physical machine, because you need a load balancer, but then who load balances the load balancer? So it's not a fully strict, but we use a tool called Traffic. It's something that grew up with Docker, because the problem is what most have is they use Nginx, and they say, okay, I know this is IP, X, Y, Z, and then you make an upstream configuration saying these 3 load balance, and then you cannot do in a dynamic environment. Because the IP addresses always change, because that's a Docker container. Each Docker container has its own IP address, so that's the virtualization which makes it really powerful. And Traffic is something that listens on the Docker daemon, and whenever a Docker daemon pulls up, this daemon reads from it, and then you label your services with the labels for Traffic, saying there's something on port, it's meant to be in that network, and it's to be accessed by this domain name or host name. And then you have a situation that whatever container you raise up, if it carries the labels, this load balancer will integrate this in the container, and will make a bucket for the name you configured it, and will all start a container, put it in a bucket, and over the bucket it will load balance. So that's a non-issue. You don't have to do anything.
So if I understand correctly, this is only part of connecting doc and has nothing to do with your Pharo images that come later.
No, because the Docker description is basically how to build, and then what ports to expose. There's an expose command. So saying, I have a container, and it has a TCP port on 3000. And that's the same thing you pick for the load balancer. And then the load balancer knows, okay, I got your IP container, and I know you're on 3000, so I integrate you in a bucket for your IP 3000. You are for this service or for another. The thing is that for your product, you label the container differently, so they are in the right bucket. So you're saying the virtual host matching in stuff is always you have a host name in a host header, HTTP, and that is your bucket. So you're saying all of these, and then you put them in, and then it's done already. Okay?
I think we should go to lunch.
Yeah.